All right, we're doing the Algebra Unit 3 Edpuzzle. This is Miss Reese. So in the first question, we are looking at a tile pattern, and we want to first start by drawing figure 0 and figure 4. So we first need to really know, well, how is this figure, how are they changing? So the first thing I like to do is kind of count the units: 1, 2, 3, 4, 5, 6, 7. So let's just write out that we have 7 units, or 7 tiles in figure 1. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can see here that we're increasing, we're adding 2 tiles. We're adding 2 tiles. So that means from figure 3 to figure 4, we're going to be adding 2 more tiles. And so we want to look at, well, where are those tiles being added? So one thing that remains consistent is these set of 3 tiles here. Those are the same in each of the figures, so nothing's changing there. So we're still going to have those 3 set of tiles on the bottom. Mine might be a little bigger than the original figure in terms of the shape. And then we want to look at, okay, well, in this, we'll call this like the middle section. We've got 4 here. Now we've got 1, 2, 3, 4, 5 in this little middle section, and now we've got 6 in this middle section. So that is increasing. Let me delete that. Okay, so we've got, let's see how many of these here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We've got here 1, 2, 3, 4, 5, 6. So we need one more. We'll add one more tile. So now we have 7 in that figure. And then in terms of what's kind of hanging out on the right-hand side, we've got 1 tile in figure 1. We've got 2 tiles in figure 2. We've got 3 tiles in figure 3. So in figure 4 on the right-hand side, we're going to have 4 tiles. 1, 2, 3, 4. 1, 2, 3, 4. So in total, we should have the 4 here. We have, I think, 7 going up and down. So 1, 2, 3, 4, 5, 6, 7. So 7 plus 4 is 11, 12, 13. So in this figure, we should have 13 tiles, and we do. So I would kind of look at this as 3 separate sections, actually. First section that doesn't change at all would be this. I'm going to use the 2 pieces here. 2 tiles. That's going to remain consistent no matter what figure you have. The next section of the tile pattern is going to be this kind of long section here. In figure 4, I had 7. In figure 3, we had 6. In figure 2, we had 5. In figure 1, we had 4. So it's looking like that's 3 more than the figure number, this middle section. And then hanging off on, see, orange. Hanging off on the right-hand side here, we've got our 3rd section of our tile pattern. That matches the figure number that we have, actually. Okay, so looking back, if we want to go to figure 1, we're going to subtract 2 from that, and so we're going to have 5 tiles. It looks like we're going to have to get rid of this piece. Okay, so we're not going to have that anymore. And then we would have to get rid of 1 in this tall row as well. Okay, so I would get rid of these 2 pieces here at the top, and then we'd be left with our 5 tiles. So let's draw that out. So we've got our 3 and then our 2 here. And so if you remember, we talked about, this tall section in the middle is 3 more than the figure number, so that makes sense. And then we still have those 2 tiles kind of hanging out on the left side. Okay, so using full sentences, we want to describe what figure 100 would look like. So we can't just like make an equation. We actually need to describe it in terms of like talking about the different pieces or parts to it. If you want to kind of describe each section, maybe we can call this section A, we can call this section B, and we can call this section C. So we have like a place to reference back to as we're going through it. So we could say something like, in section A, there will be 2 tiles. Or you could say section A, the part on the left. In the middle section, the middle tall section, and we'll put our B in parentheses, will have, and if it's a figure 100, it have 3 more than that, so 103 tiles. And the right section, the top right section, would have 100 tiles. And then we would want to say what the total number of tiles are for that. Okay, so then you might want to end with giving the total number of tiles. So if I add up 2 tiles, 103 tiles, and the 100 tiles, that would give us a total. The total tiles equals 205. Okay. Now we're going to create an equation. So remember, an equation in y equals mx plus b form. The x is the figure number, y is total number of tiles. So we're going to put this y equals mx plus b form. So we're putting in our slope or rate of change here. We're putting in our 0 with figure here. So we've got y equals, and we know we're increasing by 2 tiles every time. We went from 7 to 9 to 11 to 13. So that would be 2x, and our 0th starting value was 5, so 2x plus 5. That can also be a way to help you kind of check, like, oh, did I figure out the total number of tiles in figure 100 correctly? And if we do, 2 times 100, that's 200. If we add 5 to it, we get 205. And that's what we can do to figure out how many tiles there would be in figure 135. So remember, y is the total number of tiles, and we've got 2. We're going to put in 135. That's the figure number. And so we're just substituting 135 into that. So we're going to do 135 times 2, which is 270, plus 5. That's going to give us 275 tiles in figure 135. Okay, so for question 1B, which you are trying on your own, you are going to go ahead and draw in figure 0, draw in figure 4, and describe using complete sentences what figure 100 would look like. Okay, now I'd like for you to tell me what is the slope, what's the rate of change, what is the 0th term, how many tiles are in it, and now we'll go ahead and have you write your equation in y equals mx plus b form. And go ahead and tell me how many figures are in, or how many tiles are in figure 135. So blank number of tiles. Okay. Question 2, we're looking at an arithmetic sequence. Remember, in an arithmetic sequence, a sub n equals our common difference times n, which is the term number, plus our a sub 0. It's kind of similar to a y equals mx plus b. Okay. So we have our first term, we have our second term, third term, fourth term, etc. Remember, the formula for finding the common difference is you take the second number, 41, so second, and you subtract the first number, second minus first, or you can call it a sub 2 minus a sub 1. So our second number is 41. We're going to subtract our first number, 48. Actually, let me write this somewhere. Give myself a little more space. Let me write this over here. Oh, I'll just write this here. Our second minus our first. So 41 minus 48. And that's going to be -7. So our common difference means that we are subtracting 7 each time to get to the next term. So from 48, if I subtract 7, I'm getting to 41. Subtract 7 again, I'm getting to 34. Subtract 7 again, I'm getting to 27. Okay, now our formula for, so I'm going to just write d equals -7. That was our formula to solve for it. Our a sub 0 is you want to take the first term and subtract the common difference. So a sub 1 minus common difference. Well, we just figured out what both of those are. So we're going to do 48. That's our first number. We're going to subtract our common difference, which is a -7. When we subtract a negative, it turns into adding. We're going to be adding the 7. So this is really going to be 48 plus 7, which is 55. So that would be like our 0th term. I'm going to put the 55 over here. So imagine there's 55. And if you think about it, going from 48 to going to the right, we're subtracting. In the opposite direction, yeah, we would have to add 7. So you can also just kind of use that backtracking method. So our a sub 0 is 55. So those are the two pieces of information that we need to write out our rule. We're going to put our common difference into the rule here, and we're going to put our 0th term here. So we already have the a sub n written out, equals our common difference is -7n, and our 0th term is 55. Okay. And then we want to find out the 34th term. I mean, we could continue this list, keep repeating it, but instead we're going to put this into our formula. So a sub 34, we're going to do -7 multiplied with 34. And then we're going to add 55 to that. So let me first do -7 multiplied with 34, and that's going to be -238. We're going to add 55 to that. And our a sub 34, our 34th term in this sequence, is going to be -183. Okay, on question 2b, go ahead and tell me the common difference. The a sub 0, complete the rule, and give me a sub 34. All right, we are writing these equations in slope-intercept form. Remember, in slope-intercept form, that's y equals mx plus b. We need two pieces of information. We need our m, that's our slope. We need our b, that's our y-intercept. So remember, there's 4 types of slopes: positives, negatives, undefined, and 0. That's my slope person. This slope is a negative slope. You see it's going down from left to right. So I'm going to count the vertical units: 1, 2, 3, 4, 5. And I'm going to count the horizontal units: 1, 2, 3, 4. And that's a negative. So we went down 5 and then to the right 4. So our slope is -5/4. And then we are looking for b, that's the y-intercept. And that's going to be located right here. I just kind of highlighted that. The location of that point is at, here's 0, 0. So that's at 1, 2, 3, 4. That's 4, 0. We could give it a coordinate point there. So if it's at 4, 0, our b value is 4. So now writing our equation, it would be y equals m x plus b. Okay, go ahead and give the equation for number 3b. Okay, we're going to write this equation in slope-intercept form. I'm going to label x sub 1, y sub 1, and we have our m, our slope. So the first thing we're going to do is put this into point slope. Y minus y1 equals m times x minus x1. I'm going to go ahead and highlight. M is going to be placed here. That's going to be the 6. We're going to do our -3 into x1. That's going to be placed here. And we are going to do our y, which is going to be our y1 placed here. So now when I rewrite my equation, it's going to be y minus 8 equals 6x minus a -3. Now, when we subtract a negative, I'm just going to go ahead and turn that's going to be plus. Otherwise, you can do the step to rewrite that. This would be written in just point slope form. Now we're going to convert it into slope intercept. So I'm going to go ahead and distribute. That's going to give us y minus 8 equals 6x. 6 times x is 6x. 6 times 3 is 18. And then our last step is to subtract 8 on both sides. We want to isolate the y. We wanted to say y equals. So now we got y equals 6x plus 10. Okay, go ahead and give me the equation for b in slope-intercept form. Okay, on to number 5. We're going to write the equation again, but first let's label this x1, y1, x2, y2, and we're going to find the slope. That's our first step. We don't know the slope yet. So for whatever equation we're using, we need a slope. So remember, our slope is subtracting the y's. It is the vertical change, okay, how much we're going up and down on a graph from one point to the next, and over our horizontal change, how much we're going left or right on the graph. So if we take y2, which is 2, so y2 minus y1, so minus a negative 14. We're going to go ahead and divide that with 3 minus a negative 9. So those are going to turn into adding. So I'm going to make this plus minus a negative. We're adding that. That's going to be 2 plus 14. That's going to be 16. We're going to go 3 plus 9. That's going to be 12. And then I would simplify this. You can simplify this in your calculator, or we know that the greatest common factor would be 4. If I divide by 4, that's going to be 4/3. Now, it's not wrong if you leave it as 16 over 12. It's just, I think, a little easier to have it simplified as 4/3. Okay, so now what we can do, I'm going to put this in a point slope. I like this point a little bit better. They're smaller numbers and there's no negatives. And it doesn't matter if it's x2, y2, as long as you're using the same point, this x and y, the same point into our equation. So we're going to do y minus the y1, or we'll call this the y2, that's fine. So y minus 2 equals our slope 4/3, m, x minus x1, the 3 has to match with it, minus 3. Now you'll get the same answer if you would have used the negative 9 and 14. I just preferred the 3 and 2. Okay, so now when we go ahead and distribute, that's going to give us y minus 2 equals 4 over 3x. 4/3 of negative 3, that's going to be a negative. If you think about the 3's are going to simplify out and become 1. 3 divided by 3 is 1, and we're just going to be left with a 4. And then our last step will just be to add 2 on both sides. So that's going to give us y equals 4/3 x minus 2. That's our final equation. Okay, go ahead and give the equation for 5b. Okay, on to question 6. Write the equation in slope-intercept form. So we want this to say y equals. Right now it's in standard form. That means we need to move the x's over to the right. I'm going to subtract them on the left side of the equation, subtract them on the right side of the equation. That gives us negative 3y equals negative 5x minus 12. I just like to write the x part first. And then our last step is to divide all of our terms by that negative 3. Divide by the coefficient of y. And that's going to give us negative 3y divided by negative 3 is y. Negative 5 divided by negative 3 is 5/3. You can check that on your calculator. Make sure you place the x after it. And negative 12 divided by negative 3 is positive 4. And that's in slope-intercept form. Okay, go ahead and give the equation in slope-intercept form for question 6b. All right, we're going to select the scatter plot or select the equation that matches the scatter plot as best as it can. And you can, with a ruler, kind of, put a line that goes through, as many of these points as possible. I'm going to try to match it up a little bit here. So one thing I notice when looking at these is they all have the same intercept. Okay, so that's not going to help us. We have an intercept at 3, and that matches with our graph. What's going to help us is our slope. So if we notice this slope here, it's a positive slope. It goes from up from left to right. And also, if we think about it, so I can get rid of these two. It's not a negative slope. So we're thinking between 2 and we're thinking between 1/2. So a slope of 2 would look something like this. Like if I were making a slope triangle, 2 over 1. Okay. A slope triangle of 1/2, so that's our m equals 2, right? If we had a slope of 1/2, it would look something like this. 1 over 2. So our slope of 2 is a steeper line, and that matches this one a little bit better. So I can kind of go down 2 units here and go to the right one, and I can kind of see that that is a better match in terms of a graph. This line here is less steep, and we can see it doesn't really match with the steepness of the graph that we have. So this would be A. Okay, go ahead and select the proper answer for question 7B. All right, on to question 8. We are looking at our word problem here. And because it's asking for m and b, I know this is a slope-intercept type of question where I'm going to put it into y equals mx plus b. And we have a $35 delivery fee. And then we have 29 per cubic unit. Okay, so anytime we have something that's changing, that's going to be our rate of change or our slope. So I'm going to put 29 here. And anytime that's just kind of like a one-time setup fee, a one-time deal, that's going to be the 35 here. So our equation is going to be y equals mx, so 29x plus the 35. So when I write an equation, I like to keep the x and the y in there. Okay, now our last part is figuring out, well, if we have 6 yards, what is our cost going to be? Okay, so we're going to say y equals 29. We're going to multiply that with 6, and then we're going to add the 35 to it, the delivery fee. So I'm going to go ahead and multiply the 29 with the 6. So 29 times 6 is 174. We'll add 35 to that, and that's going to be 209. So our cost is 209. I've got to put the money sign there. Okay. All right, so for question 8B, you're going to go ahead and fill in the slope, the intercept. Go ahead and give the equation. Okay, and then go ahead and tell me the cost for 8 hours. Great, and our last question here looks like we've got a point and a point. So we're doing a point. We need to get the slope from this. So we have a monthly rent for 800 square foot office is 970. So that's our first case. So 800, comma, 975 rather. And then our second scenario is 1100 square feet, 1100, and the rent is 1,125. So we're going to write an equation for that. Okay, our first step is finding our slope, y2 minus y1. So I'm going to take our second y value, subtract our first y value. I'll take our second x value, subtract our first x value. Now this can be put all into a calculator. I'm going to do kind of step by step. Subtracting in the numerator, we get 150. And in the denominator, we should get 300. And so if we divide these by each other, 150 divided by 300 is 1/2. So our slope for that equation is 1/2. Okay. Now for this one, it doesn't specify what type of equation, so I'm just going to put this equation in point slope. This is y minus y1. I'll pick this first coordinate. So y minus the 975, y1, equals our slope, m, 1/2, x minus x1. That's the 800. Okay, so that's point slope. If you want to, you can convert that to slope intercept. And what we're trying to solve for is 1,500 square feet of office. And it actually might be easier if we convert it. I'm going to go ahead and do that. So that means multiplying by 1/2 because we're going to have to solve it for y anyways. So this is y minus 975 equals 1/2 x minus half of 800 is 400. And then we're just going to add the 975 on both sides. So 975 minus 400 is 575. So our equation, and you could actually plug this into either equation. I just kind of prefer this one. Okay, so we want to know the cost. So we want to know the value for y when our x here is 1,500 square feet. Okay, so we're going to do y equals 1/2 1,500 plus the 575. So half of 1,500 is 750. And then we're going to add 575 to that. And that's going to be a total cost of $1,325. All right, go ahead and give me the first coordinate on this next problem. Give me the second coordinate. Okay, find the slope. Write the equation. And give me the cost for 4 lessons. And that's the Edpuzzle.